All right, so what we're going to do in this video is we're going to go over some example problems with horizontally launched projectiles. And then after that, you can go to the Google Class site again, and there is a worksheet for you to give a try. There are 7 problems there. However, I just want you to do the first 4. And if you have any questions, feel free to email me, or you can join the Zoom meeting, which I just have been running just all day and answering questions as they come in. Just whichever format you prefer. Okay. So, also, quick thing. This program I'm using here, if you're not familiar with it, it is called Autodesk SketchUp or Sketchbook. It's actually a free program now. It used to be something you had to pay for, but it actually works really good. So you can change up the type of device you're using. You can be using a spray can. Just lost that. You could use a spray can or something. Markers, paint brushes, calligraphy pens, all kinds of different stuff. You can also do some symmetry things. So if you need to do any kind of like an art project, or you just want to find a way to submit your work for math or something, use this. Be a great way to do it instead of having to take a picture of something. The only thing is, this works with Windows, Mac, Android, and iOS as far as I know. I've heard mixed things on a Chromebook, and I don't have a Chromebook to try it out. So if it works on a Chromebook, comment on this post in the class site so I know whether or not it does. All right, so back to the problem. So let's start off with our launch projectile. Delta y, delta x. We'll start off with whatever v total is. So vt is 15 meters per second. And let's this time say we're trying to figure out how far away the thing lands, delta y is our big question. And we know that we are throwing this off of something rather high up. So we got that the object is 50 meters tall that we're throwing this off of, a cliff or whatever. Okay. To go ahead and get started, let's create our X and Y. Ooh, way off. X and Y chart. Sorry if things seem a little bit off. I'm using a graphics tablet, and I'm still not quite used to it yet, but I'm getting there. So values that we need in the X direction would be Vx, delta X, and T. And the Y direction, it would be VIY, VFY, delta Y, A, and T. Now, some of these values we already know, one of which is Vx, Vx being this. And it is that because of the object being launched horizontally. So this value we can say is 15 meters per second. Now to explain why that is Vx, if you were talking about an object just launched at an angle, so we'll come down here. It's launched at some value, say this 15 again, but it's not launched horizontally. It's launched at some angle. Let's call this 25 degrees. That's going to have components to it. It's going to have an X component and a Y component. So that 15 is how fast it's traveling up and to the right. But to solve problems in projectile motion, we need to know the components, the Vx and the Vy. Vx being how fast it's traveling horizontally, Vy being how fast it is traveling vertically. So if this 15 is pointed horizontally, right, then 15 is going to be in that Vx direction. So 15 is just Vx. Now, if the 15 were shot straight upward, that is now in the y direction, and Vt, the 15, is just Vy. Since it's directed at some kind of an angle, then it's going to be you're going to have portions. You're going to have a part of this 15 is Vx, and a portion of it is Vy. So in this situation, it's just going to be Vx. Viy, since it is launched horizontally, would be 0. There will be no y component to this. Delta y we are given. Height of the cliff, the overall distance the object falls. Acceleration is a constant negative 9.81 meters per second squared, so we have it. The big question is this: what is delta x? If we look at our equations, we know that delta x has one equation to solve for. Delta x equals vxt. We have vx. We have this. We don't have time. So we got to figure out time first. And the only way we can figure out time is to go to your y values, your y directions. So let's go to the delta y equals VIYT plus 1/2 AT squared equation. We're going to plug in our delta y, negative 50. It is launched horizontally. We said VIY is 0, so this is 0t plus 1/2 negative 9.81 t squared. Negative 50 continues on. This drops out. This whole term goes away, and you get 1/2 negative 9.81 t squared. So negative 50 equals negative 4.905 t squared. Get the calculator out. You get 10.19 after you divide your 4.905 over. And then t is the square root of that 10.19. Which is 3.19 seconds. That equals t. So that's part of our answer. We can take that up here. Remember that time is a crossover variable. It is the same in both the x and y directions. Let's get that on both sides. So now we have a t. We can figure out what delta x is out now, how far it goes. Because if it's going to fall for 3.19 seconds vertically, it's also going to travel horizontally for 3.19 seconds. So delta x equals vxt. So 15 times our 3.19 and we get 47.88 meters. All right. Now that's all that's really asked for in the problem. But if we wanted to go further and figure out some more values with this, figure out what is VF here. What is the total velocity that this thing is traveling at when it hits the ground? So what is VT? All right, V total. Well, to figure out V total, we would need to figure out VFY, because the total would be something like this, but the arrow is going to be drawn off and to the right instead. So we'll get this one out of the way. we're looking for VT. VT is going to have those components. It's going to have an X component. Move VT to the bottom side here. It's going to have an X component to it. And it's going to have a Y component to it as well. Now the X component we already have. Okay, we already have that. It's 15 meters per second. Okay, so we already have this. Because the horizontal velocity is constant at all points in time. So no matter where you are in the motion, whether it's at the beginning, at the end, somewhere in between, Vx is 15. Now your Y, however, is going to change because it starts off at 0. As it falls, it's going to be accelerated downward because of gravity. So the longer it falls, the faster the thing is going to be going. So we need to figure out what Vy is at this moment to figure out this value so we can figure out V total. And what is Vy at this moment? Well, that's the very end. So that is Vfy. So what equation can we use to figure out that one? We can use the Vfy equals Viy plus AT. That is the simplest way to do this. We've already figured out time. We can be fairly confident in our answer for time, so we can go ahead and find out Vf with it. So Vfy equals 0 plus negative 9.81 t. Plug in our 3.19 for the time. It comes out to 32.29 meters per second. So we get negative 32.29 meters per second. So that's our Vfy. We have this value now. We still need to figure out Vt, the total. Now this little triangle we have made out of the components of the velocity is a right triangle. So because of that, we have two sides. We're looking for what's the hypotenuse. So V total would be Vt squared equals Vx squared plus Vy squared. So Vt squared equals 15 squared plus 32.29 squared. So Vt squared equals 1,267.64. And then Vt is the square root of that. And you get 35.60 meters per second. You may wonder why I didn't put a negative here for negative 32.29. The reason I didn't is because once you square it, it's just going to cancel out anyway, so I didn't bother putting it in there. Now this Vt is going to be the magnitude of the value for velocity. We still need to know a direction. We know that this length is 35.60. We don't know this angle, okay, the angle theta. This is going to be our last step of the equation, or last step of the process. And use the inverse tan function of the y component over the x component. So 32.29. I'm also dropping the negative here because I'm just looking at the angle measurement of a triangle, and generally speaking, we don't have negative lengths for triangles, right? It's going to be kind of weird. All right, so we do inverse tan of 32.29 divided by the 15, and we get 65.08 degrees. As our angle theta. So we want to ask ourselves, what is our answer for that one? What is VT? The answer would be VT equals 35.60 meters per second at an angle of 65.08 degrees below the positive x-axis. It's because if you were to draw this out, your x-axis runs this way, your y-axis runs vertically, so it's below that positive x. And that's one way you can go ahead and write that. So there's a fully worked out example